that up with either the location of the file system or the swapping file system or -A to indicate that swap on is to read from FS tab. So if you execute swap on, for example, with no options, you'll see that it has the options HV, AEV, so on and so forth. You can indicate a device directly, but if you want swap on to simply read what's in FS tab, you use the -A option. For now, since we have an updated etc FS tab, let's execute swap on dev SDB2. We'll copy and paste, and then the kernel will attempt to allocate the storage. Again, it's now half a gig. Now we've executed swap on dev SDB2. Now we'll execute free-m again, and it's been doubled to a gigabyte. So we can execute swap on with a partition. This enables swapping for dev SDB2 or on dev SDB2. The next step is to update etc FS tab so that when the system reboots or if we execute swap on -A, this device, SDB2, will be included in the pool of available swap storage. Before doing so, let's now take a look at our swap report using swap on -S. We now see that there are two devices, SDA6, the first partition, or the sixth partition on the first hard drive, that is, as well as the second partition on the second hard drive. Both are available. There's also a priority set which indicates which swap partition will be used. Now let's nano etc FS tab. We'll find where swap is defined, and we can just place the raw partition here, which is dev SDB2. It's of type swap, defaults, and it isn't to be checked when the system starts. We can even include a comment. Newly created 512 megabyte swap partition. And this will get mounted whenever we reboot the system, or if we turn swapping off and then re-execute swap on -A, it'll be re-enabled. For example, just like you have swap on, you've got swap off. Swap off with no options returns options that are similar to swap on. Swap off, dev SDB2, for example, will turn off swapping on that device, and you can confirm as such by executing swap on -S. You can also further confirm by executing free-m. So let's just note, we've updated etc FS tab. We've included dev SDB2 type swap, swap, defaults, 00, so it's not checked. Swap off, dev SDB2 disables swapping on dev SDB2. Now supposing we want to increase performance, so improve system performance by distributing swapping to dev SDB2. To do so, we need to disable swapping from dev SDA6. So first, swap off dev SDA6. But of course we need to turn on swapping somewhere, so let's label as our first task swap on dev SDA or SDB2. Then the second task will be to turn off swapping on dev SDA6 to be sure that we have some swap space, although we currently are not using it. Let's confirm that this is in use by using swap on -S. Both are in use, dev SDA6, dev SDB2. Now let's turn off swapping on the primary hard drive, which is being used to house the root, home, and boot file systems. The exit status is clean, and now we'll again execute swap on -S. So now swapping is only occurring on the second hard drive on the second partition. Free-m will reveal that there's still roughly half a gig of memory available for swapping, but no longer are we swapping on on the primary hard drive. Now back to swap on-A. If you execute swap on-A, it will attempt to turn on swapping on all devices. Notice an error is returned for SDB2 because it's already on. However, if we execute free-M, you'll see that we're back to where we were earlier, and that is if we execute swap on-S, swapping on two devices, SDA6 and SDB2. So let's swap off dev SDA6, then update our ETCFS tab. So altogether we need to improve performance, and that's also going to be enabled by disabling. So disable dev SDA6 via ETCFS tab. Let's give that a try. We'll search for the first swap instance, and there it is. This is the SDA6 entry. We'll ensure that everything's on the same line. We can even include disable to improve performance. So now we've updated FS tab. Swap on-S shows that only one device, and now when we re-execute swap on-A and re-execute swap on-S, we see only one device available for that purpose. So now when the system reboots, we're guaranteed that swapping will be brought up on the second hard drive, not the first. And this is a way to improve performance. Now we've shown you now how to, or thus far, how to create swapping based on a partition. But it's also possible in Linux, like so many other things, to create swapping based on a file. So we like to show this as well, because sometimes it isn't feasible to create a swap partition because you may be out of partition space. You may have used all of your hard drive space for user space and swap partitions and need emergency swap space. So this section we'll call create swap based on file. And again, features include the ability to provision swap space based on a file similar to pagefile.sys in Windows, NT, etc. if you have no available disk space to partition. Doesn't mean you don't have disk space altogether. It just means you don't have free space to partition. So you may have used all of the available space on the hard drive, but within each file system you may have many megabytes or gigabytes available that can be used for a swap file. So that said, it's important to know how to create a swap file and then reference it using swap on. We'll list those two that it doesn't waste partitions. Now with that said, let's show you how it works. We need a task as usual, create swap file. Let's make it 512 megabytes, or half a gig. So to do so, we're going to use the dd command. We'll set an input file of dev0, so it'll write zeros to it. Dev0 is a facility, again, which allows you to write zeros when used in conjunction with the dd command. But we need to send dev0 to an output file. dd supports input as well as output, as well as other options such as byte size, and it can do it for a certain count, whatever count specified. So the output file will be equal to somewhere where we have space, and let's just find that space, 512 megabytes. We'll clear screen df-h to see where 512 megs is available. We have that space available in home 1. Home 1 is on the second hard drive, so this is an ideal place to put it. So output file will be /home1, and we'll call it swap file 1. The byte size, we'll set it to 1024, and when you multiply 1024 by a number, you need it to add up to 512 million bytes. That count would be 524,288. So when you multiply this times this, you get roughly half a gigabyte. Open a calculator, try it, you'll see. So to recap, the dd command, which is useful for many things, for sending output based on an input, will be used and will reference deb0. So deb0 will serve as a source of writing information, similar to how we've used sequence to generate n number of numbers, such as 1,000,000, 10,000,000, 1,000, so on and so forth. Deb0, with the help of dd and its byte size and count features, will send the output into a file beneath home1 named swapfile1. The entries will be of size 1024, and it will be repeated 524,288 times, consequently making a half a gig file. Once that file has been created, we'll use make swap and then swap on, and then that's it. So let's create that file. Again, you need to identify where free space is available. Now this takes a little while to write the half a gigabyte file, so we just have to wait it out. But if you have another shell open, you can confirm as the file is being written to the hard drive that it's indeed doing what it's supposed to do. Again, dd is just that facility which allows you to take an input such as deb0, but it doesn't have to be deb0. You can take an input of a file and send it as output to some other facility or some other file. So here we see 524,288 records in and out, totaling 537 megabytes, slightly larger, but it's in the ballpark of what we want. dd also returns the amount of time the process took, just under 25 seconds. It also returns the bandwidth. This is the disk-based bandwidth of 21.5 megabytes that is, per second. Multiply this by 8, and in network terminology, that's about 160 plus megabits per second. So it's really fast. Let's confirm that the file exists using lsltrh home1 swap file 1. There it is. Now if you're concerned about what the file looks like internally, less home1 swap file 1, and it tells you it's binary. So there's nothing much we can do with it. Now we need to turn on the file system, the swap file system. So step 2, which we'll list as B, is to execute make swap